Now, in this video and the upcoming videos, we'll be going over and walking through a machine learning project. It would be targeting the beginners. So let's get started. So first, I am on the UCI ML repository page, and we will select the dataset, which should be beginner friendly. So the attribute type I've selected is numerical, since we will not be dealing with any categorical variable or attributes right now. Number of attributes I've kept less than 10, so that I don't need to reduce or do any feature selection. And finally, the task is of a simple regression task. The first one, after applying the filters, the first dataset that pops up is the computer hardware dataset. So let's take a look, and here we see we need to find the relative CPU performance. It's given. They are giving us relative CPU performance in terms of its cycle time and memory size. We have 209 instances, 9 attributes, regression task. Okay. Some additional information. There are no missing values. Great. Some additional information. So this is our attribute information. We will be using this, and that is also, there are some citations also. Next, we'll go and download this dataset. So I've already downloaded it. Let's take a look. So you will get a zip file. Once you extract the file, you will get 3 files. So let's open in Notepad. First one is simple index, listing out the names of files. Second is the .data file, machine.data, which contains the CSV formatted data, which should be at 209 instances. And finally, we have machine.names. Let's see what it contains. It contains the attribute information. So first one is title, second is source info, usage, relevant info. Okay, it's not titles, it's generic information about the dataset. The attribute information is again here. No missing values. Class distribution is also given. Stats of the summary is given, and you can see the correlation as well. Looks good. Looks good. PRP is the published relative performance. ERP is the estimated relative performance from the original article. Okay. So this was a brief about the dataset that we'll be taking up. In the next videos, we will use this dataset and develop a machine learning project out of it. In this video, we will be learning how to load the dataset that we just downloaded. So in the last section, we just downloaded the dataset from the UCI repo. Now to load the dataset, we'll be using an offering provided by Google, which is Google Colab. It's a free service offered by Google. You need to have a Google account to access it. So I'll post the link in the description. Next, we will be adding the dataset that we just downloaded. For that, you can see a left file icon on the left sidebar. Click on it. Wait for it to connect to a runtime. It might take a few seconds. Once done, you should be able to see the file listings. Right click, upload, go to where you have downloaded and extracted the data. So I'll just push the data, upload the data. Once done, you will find it here. Next, we will be loading the data set into Python using Pandas library. So before that, since we've already had a sneak peek of the video of the data, we know that the data only contains values. It does not contain the headers of the column. So we have to address it. Apart from this, we need to know what does each column mean, and that information, that is the attribute information, we'll find over here. So I'll just copy it and paste it here for reference. Double click. Paste. Should be fine then. This is the attribute information. Let me edit attribute information. Next, we will be preparing our load our dataset. So let me again type a section. Load libraries and dataset. Now first we need to import pandas. Import pandas as PD. Once done, let's import pd.readcsv, and we need to pass in the path for the data file or the CSV file. So right click, copy path, paste, and let's do a data.head. Head basically prints out the first 5 rows. So control enter, and you should see the first 5 rows. Now notice that the first or the columns, the column names that it suggests is not the column name, it is the data. For that, you can use an optional header or optional parameter, header equals none, which basically helps pandas to identify that the data that you're passing it does not contain any header, which is the column names. Now if I run the data.head, you'll see 0, 1, 2, 3, which is just the number of columns, which is 10 columns. Now we will use names, so let's create names, create tree, an array, and let's see here. So we have vendor names. Okay, let me do a slight manipulation. Let me call it PR. Next, we'll just write in names as we know the attribute information. So first is the vendor, second is the model name. So MOD is the model name, MYCT. means MYCT is the cycle time in nanoseconds. MMN is the minimum mean memory, and M max is the max min memory. We have cache, CSCH, we have CH min, and CH max. We have PRP, and we have ERP. I'll hit shift enter, control enter, nothing. So we need to pass in the names in the read CSV. So names equals names. This is again one of the optional parameters provided by pandas. And now we can see the names of the columns as well as the data first 5 rows. So that's it in this video. In this video, we will be going over how to show or how to infer some of the descriptive statistics from the data that we have loaded. So first, let me, without further ado, get started. First, let's just clean this text, load libraries, and this will be loading to dataset. And this part will be where we will be summarizing our data. Summarize data. And we'll start off with some of the descriptive statistics. And the reason I'm doing this is because if you move to the table of contents, you will soon see it being aligned. So whenever you want to add any libraries, you can click on Load Libraries, you'll be redirected to the libraries element. Now, first is the data.head. Let me run this once again. It pops out top 5 rows, and we can infer some of the data. For example, here you can see the PRP and the ERP column are very closely interlinked. 198, 199, 132, 132. There are odd differences like 172, 253, row number 3, but on a high level, you can say that these two columns are very highly correlated or linked to each other. Next, let's look at the shape of the data. So we have 209 rows and 10 columns, which are VEN to ERP. Next, let's look at the types that we are dealing with, data.b types. So our VEN and MOD, which is the vendor and the model column, are objects, and you can confirm the same here. So vendor is advisor, AMDEL, model is 32 by 60, 470 V by 7, so on and so forth. And the rest, all of the values or all of the columns are integer types. Looks good. Next, let's describe the data. It will collate some stats across all of the numerical columns, which means count of the columns, so we don't have any missing value. We have the mean. Again, you can see mean is slightly different: 203, 2000, 11,000, 25, 4, 18, so on and so forth. So mean varies. In some cases, it's in 3-digit, 2-digit, single, even 4 digits. Deviation is the same. It also varies across columns. So it might be a good idea to transform these columns so that their mean and standard deviation could be brought down to a similar scale. Again, in this project, in this machine learning project, we will not dive deeper into transformations. We'll go over a high level view, but it's a good thing to keep in mind for future projects. Next, we'll look at the correlation of all the columns. Now we need to pass a parameter numeric only equals true, since correlation is only applied to numerical columns. Of course, we can convert these strings, vendor and model or objects, to numerics, but we will take a bit later. So here data.co correlation numerically true, and it pops out saying that the ERP, which is the one we will be predicting, is sort of inversely related to MYCT. It's highly 0.82 minimum memory, minimum main memory. Mmax, which is the maximum main memory, it's 0.9 correlation. Cache is 0.6, 0.6 with cycles, minimum cycles, 0.59, maximum cycles, 0.9697 if I round off. PRP, again, as we could infer earlier from these rows, both of these columns are highly correlated. And finally, let's look at one more, which is the skew. So again, numeric only. And now it says 2, 3, 2, 4, 3, 3, 4. So in general, whatever number we are presented with, if it's positive, it means that the curve or the values of the column are right skewed. If it's negative, it's less skewed. In general, what we want to achieve is for this skewness to be as close to 0 as possible, which would mean that it depicts a bell-shaped curve or a Gaussian curve. So these are the descriptive stats for this data set. In this video, we will be going over some of the data visualizations that we can infer out of this data set. So without further ado, let's get started. First, let me add a section for the data visualization. Next, we will start off with plotting a histogram. So doing so should be easy enough. Data.hist and plot.show. So one thing that I added in was 3 libraries with 2 couple of libraries. One is matplotlib.pyplot as PLD, and the second one is Seaborn, both of which we will be requiring in this video. So once I run this, I should get a histogram. There it is. Now, in this histogram, the attributes as the labels and the legends of the chart or of the each individual's plot seems to be overriding. So either we can disable the legends. In my case, I'll just reduce the label size to 6. Same with Y. Let's see. It's fine. So it's fine for me, but if you want, you can go ahead and remove the attributes and legends as well. To do that, move over to Panda's documentation. You'll see dataframe.hist, or you can just search for .hist, which is the method that we used. Dataframe.hist, and it will give you the representation of all the docs, all the parameters that this method supports. So we have used only 2, X label size, Y label size. You can check if there is any other that you find interesting and want to use. Next, we will plot let's see, a density plot. So data.plot.density, plt.show. Let's see. Okay. So as you can see, all of the labels or attributes are being pushed into a single plot. Now we don't want this. We want each attribute to have its own plot. So for which we will pass in or use the parameters of plots. So plots equals to, which basically will help us to move all the attributes to their specific plot. Next, there seems to be some problem with, so here the data only lies between all of the scaling, the X axis seems to share the same scale, and we don't want that. We want share X equals what? Okay, now each plot has its own X axis. Next, let us make it a little better layout. 3, since we have 8 plots. So this seems good enough. You can go ahead and reduce your label size or do anything else you want, but for me this is sufficient. So as you can see, with both these plots, the graphs or the data plots have a right skewed values in almost all of these columns, and which we already inferred from our data.skew descriptive stat. Now finally, we will plot a correlation matrix for which we would need the correlation values. So CORR, matrix values, let us say data.CORR, numeric only true. This is the same that we used in the descriptive stats portion. Next we would have let's assign this figure size. So figure size 10,8. Next, let us use Seaborn that we installed or imported to plot the heat map with the correlation values. Then let us give a title to our plot, correlation matrix, and then just show the plot. This works. Okay. So here, as you can see, the lighter values show higher correlation and the darker values show lower correlation. Apart from this, we are not able to, this seems to be a pictorial representation. Let us add some annotations as well. So annote equals true for adding annotations, and let's see, C map, which is the color map, cool form, shifting to a different theme in simple words. Now here we have 1, which is of course the most correlated one with itself, and the lower values are very low or less opposite correlated. And as you can see, the ERP and PRP are almost equivalent, 0.97 and 1. 0.9 with Mmax and 0.82 with M. Seems good. Seems good. In this video, we will be going over some of the pre-processing steps involved while creating a machine learning project. Now, we will keep it simple and only perform some of the data cleaning tasks. So, without further ado, let's get started. First, I'll be creating a section for process data. Next, let me create one more section which would be clean data. As you can see, both of them should be here. So the first step we will perform is to check whether our dataset has any duplicated rows. For this, we have a method provided to us via Finalize, which is data.duplicated, which returns all of the instances or all of the rows in the dataset and will associate a Boolean value whether it is a duplicate or not. So we will check duplicated rows equals data, and if we did found any duplicated rows, if not, then just print no duplicate rows. So just a brief that this dataset will not contain most of the pre-processing steps, but we will do check if we need to perform or not, or what are the steps that we need to check. Next, we will check if our dataset has any single value columns, for which the method we will use is data.inUnique. Now it will return us list of all the rows. Associated with it will be a number which shows the unique or distinct values in the dataset or in the column. So we will say single value columns equals data.columns, and if the single value columns is empty, then just print no single value columns equals to 1. Since we want the distinct values to be equal to 1, which is the single value column. Next, we will check if there is any missing data in the dataset or missing cell, for which there is a method data.isAny, which gives us a list of true and false for all of the individual cells in the dataset. If we do isAny, then it will give us a list of all the columns associated with a flag which tells us if the column has any missing value. So missing value column equals data.columns, and if missing value columns any, then no missing value. In this dataset, there is no duplicate rows, neither is there any column with a single value, and also we check that the dataset does not contain any missing value. So that's it for the pre-processing steps we will do for this simple or basic project. In the next video, we will run our model through an algorithm to give us a model. We will train the model and as well test it and check what is its metric. In this video, we will be going over how to evaluate our machine learning model that we'll create. In this video, we will use a model, specifically linear regression, train the data and test the model, how it performs, and see a couple of evaluation metrics along the way. So without further ado, let's get started. First, let me create a section as always. It will be, let's say, evaluation or evaluate algorithm. Next, let's split our dataset into two parts, X and Y. X and Y. So X will be the list of our features that we want to train our model on, and Y will be the attribute or the feature that we are trying to predict. In this case, the ERP for the CPU. So data.iloc. Now, if you remember, we have 1 to 10 columns, out of which first and second are objects, VUN and MOD, which is the vendor and the model. So we will skip those 2 columns. We will take from M by city, which is the third column indexed 2, till PRP. Okay. So let us do it. Colon, comma, so and 2 colon minus 1. So the left side of the comma is denoting that we need to take up all the rows of the dataset. And the right part, 2 colon minus 1, denotes that we are skipping 0th and first column till minus 1, which is the till second last column. And this will be pretty easy. I lock filling all the rows and columns of the last. So this is exclusive. So the right hand side or the right part of the colon is exclusive. Hence it excludes the last column. We'll execute it. Good. Next, we will split our dataset into train and test portions. For this, we need to import a library, a method from the sklearn library. So from sklearn.model selection, import train test split. Next, we will use this train test split. First, we pass in X, which is data, Y, which is the feature data, and the test size, which is pointed. Now, this is not a categorical ML model where you need to predict a class for each of the instance. Hence, we are not using Stratify, which is one of the parameters that you would typically use in a categorical project. So it returns 4 values, which will be X train, X test, Y train, and Y test. Awesome. Let's print the shape as well, post, and before and after the split, X test, 209.2, which means 20% would be in the data tester data, 42, and the remaining 167 are in the training data. Next, we will use one of the simplest of regression models, which is a linear regression. That is imported from sklearn dot linear model. Import linear regression. And so let's use that model. Model equals linear regression. And we will also fit our data, which is the train and test data. Not test, train and Y train. So X is the data and Y is the feature data labels. And next, we will find out what is the training accuracy for which, and since it is a regression based model, we can use multiple attributes or evaluation metrics. But for now, let us use sklearn from sklearn or metrics and mean absolute error and R2 score. So it should be fine. Come back to our evaluate algorithm. Then we will first find out the predictions from our training model, from our model on the training dataset. Model.predict xtrain, and the metrics that we want to use for finding that evaluating our model will be MAE. So MAE, which is the mean absolute error. So mean absolute error, and the other one is R2 or R square, which is R2 underscore score. For these metrics, we pass on a loop our metric in metrics and print it out as metric for the Y train, which is the actual labeled data and what our model predicted that data, and we'll print it out like this format, name and the result. So the MAE, which is the absolute error for our training model, is 19.08, which means on average there is a deviation of 19 units, and R2 being 0.96. Now, one insight on R2 is the closer R2, the range of R2 lies from 0 to 1, 0 implying completely misfit and 1 implying perfect fit. So ideally the value would be between 0 and 1. The more closer to 1, the better the model is. And since the value is quite high, basically implies that the model is pretty straightforward, and hopefully we can test it to make sure it is working correctly. So model.predict will do the same this time with test data. we have already taken up the metrics, so that is fine. And here I'll pass the y test and the bench test, which the model has predicted. Me2, so we can see our average deviation is higher compared to our training data, and the R2 result is 0.86, which is, to be honest, on the lower end compared to our training. But see, 0.86, fair enough. Awesome. So I think those were the parts that we wanted to cover in this video. In this video, we'll try to add a section wherein we will take a look on how to finalize the model. It will include saving the model, loading the model, and using the loaded model to score some of the predictions and to get some predictions. So without further ado, let's get started. First, we will add a section, as always. Finalize model. Let's take it. Yeah, it's visible. Next, we will name the model. Let's say model name equals CPU ERP.pickle. Why pickle? Because we are going to use a library which will be pickle library. Import pickle. Loaded. We'll move to finalize model. Then pickle.dump. We will pass in the model that we have computed so far, which is this model, linear regression model. Next, we will pass in an option to open the file with the model name, and the specific setting in which we want to open the file, which will be RB. So if I open the file section and I run this cell, pkl.dump, it's not loaded yet. Pickle PICKL. Okay. It cannot read because it does not exist. It is WP. Yes. So if I now open the files, you'll see this ERP pickle 652 bytes. Now I'll load the model. Loaded model equals pickle.load. Now here I'll open the file in read-only mode. Awesome. The file is loaded now. Next, I'll use that loaded model to score our test and print the score. R2 and the result. By default, the score method gives us the result of this R2 score. I'll also pass in the by test, and I have to make a prediction. 0.96, which is the same as this earlier with the scored model, with the trained model. So that's a brief on how to save, load, and use the loaded model. Thanks for watching. Bye-bye.